Algebra 2 6.6, Solve Rational Equations. Now there's 10 videos before this one for Chapter 6, and you might become lost or confused if you haven't seen them because we're slowly increasing our knowledge here. And you can just click on this video's description and watch them very quickly. A rational equation will contain one or more rational expression, like this. And to solve a rational equation, we multiply every single term by the LCD, that least common denominator, to clear the fractions. So if we have 2/3 minus 5/6 equals 1 over x, we can see that we have a denominator of a 3, a 6, and an x, so our LCD is 6x. We multiply every single term by that 6x over 1, and when we multiply it, every term, don't forget, even on the other side of the equal sign and this guy in the middle, we're going to get a 12x over 3 minus 30x over 6 and a 6x over x. These two x's are going to be a 1 because it's the same numerator and denominator. See? Because it's 6 times x over x. So that's going to cancel out as a 1, and we'll just have a 6 on this side. And this will be a 4x minus 5x. Well, that's a negative 1x, and we don't write the 1, right? To get rid of this negative sign by the variable, we just divide each side of the equal sign by that negative 1, and we get x is equal to negative 6. And if we plug this negative 6 back into the original equation, we'll find out it makes everything true, and we're fine, and we solved it, okay? But sometimes when we multiply each term by an expression that contains a variable, we may not get an equivalent equation, and the new equation may have solutions that the original one doesn't. So we must always check the possible solutions in the original equation. We have got x minus 1 over x minus 5 equals 4 over x minus 5, and it's very easy to see the least common denominator is x minus 5. That's an easy one, isn't it? So we're going to multiply each side by that x minus 5. We can write it over one fraction bar, and we get x minus 1 times x minus 5 over a 1 times an x minus 5, which is really just x minus 5. We get 4 times x minus 5 over x minus 5, see? And this cancels out as a 1. This cancels out as a 1. So we end up with x minus 1 equals 4. We can add the 1 to each side and see that x equals 5. Now when we plug in x equals 5 into this original equation, we're going to get 5 minus 1 over 5 minus 5. I already see a problem. That's going to make a 0, isn't it? That's undefined. So I don't even need to go on to this side. You know, I could, but I already know that we've got a 4 over a 0, and that means 5 can't be a solution. There's no solution. So that could trick you on a test. You'll say, oh, I got it, x equals 5. You'll fill in that little circle saying x equals 5. But if you had checked it, you'd see that the real answer was no solution. Okay? So be careful. You got to check. All right, let's take a look at this one. We've got x squared over x minus 2 equals 4 over x minus 2. Our lowest common denominator is easy to see that it's x minus 2. We multiply each side of the equation, each term, by that x minus 2. I can put it over a 1 to make it easier on your eyes. So now that means we have x squared times x minus 2 over 1 times x minus 2. This makes a 1, doesn't it? Same numerator and denominator. And it does the same thing here, same numerator and denominator. So what we're left with is x squared equals 4. Now we can use the principle of zero products that we learned back in 2.1c, and I'll have a link to that video in this video's description in case you forgot how to do that. We set it to equal to 0, so I'm going to subtract 4 from each side of the equation so that this side will be 0, and we have x squared minus 4. Now all we have to do is factor it. When we factor x squared minus 4 is x plus 2x minus 2, and we set it to equal 0. Then we break it up and say, well, x plus 2 equals 0 or x minus 2 equals 0. We can use additive inverses to isolate that x, and we get x equals a negative 2 or x equals a positive 2. Now we plug the negative 2 in to check it, and then we plug in the positive 2 in to check it. When we plug in the negative 2 into the original equation, see, put negative 2 squared, negative 2 minus 2 equals 4 over negative 2 minus 2. We end up with 4 over negative 4 equals 4 over negative 4. So yeah, negative 2 is a solution. When we plug in the positive 2, though, look, we get 0 denominators. So no, negative 2 is a solution, but the positive 2 isn't. Okay? Let's try another one. We've got x plus 6 over x equals 5. We can see the LCD is an x. It's the only one there, isn't it? Because the rest would have a 1 underneath them if they were fractions. So we multiply every single term by that x. This makes x squared plus, these two x's cancel each other out as a 1. So we got a 6 over a 1, which is a 6. And it's going to equal 5x. We use that principle of zero products again. We're going to set it to equal 0. So we need to subtract that 5x from each side of the equation so that this side is a 0. We get x squared minus 5x plus 6 equals 0. And we factor this, and we get x minus 3 times x minus 2. We set each parentheses to equal 0. We use our additive inverses to isolate the x, and we get x is equal to a 3 or x is equal to a 2. We plug them in, the 3 for x, and we get 3 plus 6 over 3, which is a 2. 3 plus 2 is 5. So yeah, 3 works. 2 plus 6 over 2, that's 2 plus 3 is 5. Yep. So they're both solutions. Just remember that the denominator can't be 0 because otherwise it's undefined, okay? All right, here's our last one. And you can see that what we had to do before we could even do this one was we had to factor that denominator. And our LCD ends up becoming x plus 5, x minus 5. Because that's what this would be factored, and we have an x plus 5, x minus 5 here. So now what we get is, for this term, we get 2 times x plus 5 x minus times x minus 5, and it's going to be over a 1 times x plus 5. See that? And if you look, these two can cancel out as a 1. So all we're left with is this 2 times x minus 5 over 1, okay? And for the 1 over x minus 5, we multiply it by the LCD, and we can see the x minus 5 down here is going to cancel out with a 1 as a 1 with this one, isn't it? So we're going to be left with 1 times x plus 5 over 1, okay? And then this one that we factored is going to have this denominator, isn't it? So we're going to have 16 times the x plus 5 times the x minus 5 over that denominator, and that cancels out as a 1, that cancels out as a 1, so we're just left with 16. So now what we've got is 2x minus 10 plus x plus 5 equals 16. We combine the like terms, and negative 10 and 5 is a negative 5. We subtract 5 from each side of the equation to isolate this x. We get 3x equals 21. We divide each side by the coefficient 3, and we get x equals 7. Now let's plug that 7 in. Let's substitute them into this original equation and see if it works. So now we've got 2 over 7 plus 5, that's 2 over 12. And 1 over 7 minus 5, that's a half. 16 over 7 squared minus 25 is 16 over 49 minus 25, which is 16 24ths. We find common denominators to add them, and we get 4 24ths plus 12 24ths equals 16 24ths, and yep, that's true. So we know 7 checked out, and it was a solution. Okay? So our next video is 6.7. We're going to talk about solving work problems using rational equations. So they're going to be word problems of work problems. And I'm going to add this video to the Algebra 2 playlist so you can use it to study. And 10.6 and 10.7 from Algebra 1. Those links are going to be in this description too, along with all these other Algebra 1 videos that we covered all of this, okay? And all the Chapter 6 videos for Algebra 2 that we just did, those links are going to be in this description also. So it's going to be a very, very long line of links, okay? Right at your fingertips. Just click on it and you'll be able to do all your studying and reviewing. And when I was in high school, boy, we didn't have YouTube. We didn't even have internet. And I sure wish I had something like this so that when I came home, I wasn't so confused. We used to have to wait and make an appointment with the teacher to find out what we missed. I'll see you next video. Keep trying. I'm proud of you. Bye.